Hello and welcome to this introductory video for the LCA foreground modelling software lcopt. In this video I'm going to explain how to turn a process flow diagram into a working LCA foreground model using lcopt. We're going to be doing this by looking at a cup of tea. The first thing you should do when you start a new LCA project is to draw a process flow diagram. So here's me drawing a process flow diagram to make a cup of tea. We're going to need the kettle. The inputs to this to make boiling water are water and electricity, and we're going to need a teapot. We add our boiling water from our kettle to our teapot, along with some tea leaves, to create our output of black tea. This goes into a teacup, where we can add our milk. Now we know what we're modelling, let's open up lcopt and we can start the modelling process. So we go to the Start menu and find lcopt in our list of programs and click on lcopt Launcher. Wait for a second and it will bring up the lcopt Launcher screen and we can create a new project with a sensible name. lcopt opens in the web browser, but you don't need to be connected to the internet to use it. The interface is designed to be intuitive, with more info icons dotted around to try to help you if you get stuck. Right, let's start building our model. The first thing we need is a new process, so we click on the Add Process button and give our new process a name. This is going to be the kettle. The output of our kettle is boiling water. We'll leave the units as kilograms and we'll click OK. We can position this process anywhere we like in the flow sheet. Next, we click on the Add Input button and begin to add inputs to the kettle. The first input we need is water. So we're going to search for tap water using market processes. Market processes are recommended to be used by EcoInvent for when you don't know the exact supplier. Find the market for tap water, we click OK to add our first input. This, like the other process, can be moved around to wherever we like in our flow sheet. Let's add a second input, this time electricity. Searching for LCI data, we'll search for electricity. This time we're going to specify a location, in our case Sweden. Again, using market processes, and find the market for medium voltage electricity. Let's continue to add more processes to our flowchart. The next process is the teapot, the output of which is black tea. Move this into position. And then we can link the kettle, which outputs boiling water, to our teapot. As we move this item around the flow sheet, the links stay connected. The input we require here are tea leaves. Searching for tea gives us some potentially unexpected results. It's found the letters TEA in Steam. We can either scroll down to find the tea that we want or add dried to the description in order to identify tea leaves. The final process we need is the teacup, and we'll call the output tea. Drag this into position and we can link the black tea from the teapot to our teacup. We'll add milk as an input. Again, searching for market processes and finding the market for cow milk. We now have a model which closely resembles the flowchart that we drew on the piece of paper earlier. As we can see, we have elements and we have links, but our model is not yet ready to analyze because we need a parameter set. The parameter set defines the amounts that relate to each of the flows in the model. Each unit process has its own section in the parameter set screen with a production parameter and input parameters which we need to define. We'll begin by defining the inputs to the teapot. 20 grams of tea and 980 grams of water. Next we will do the teacup. Here we have 50 grams of milk and 950 grams of tea for every litre of tea that we're making. We can click the Save button to save our parameters. Finally, the kettle. The information we have about our kettle is that it has a capacity of 1.7 litres and so requires 1.7 litres of water to fill it, and that it has a power rating of 3 kilowatts and takes 2.5 minutes to boil a full kettle. We can use global parameters to calculate this as part of the model. We click on Add Global Parameter, add an ID for this parameter and give it a sensible name. The unit in this case is kilowatts and the default value is 3. We'll add a second global parameter. This one is the boil time. Again with a sensible name. The unit of minutes and the default value of 2.5. Note that the spaces we've left in the ID are automatically turned into underscores in the parameter ID. We now have the building blocks for our function to define electricity use, so we can click on the Add Function button and start to build our function. In the drop-down list are all of the parameters we can use. These include the input and production parameters, as well as our global parameters. The formula we want is the power rating multiplied by the time in minutes divided by 60 in order to convert to hours. We can search for our parameters in the drop-down menu, complete our function, and there we have it. As we click Save, the function now defines the electricity parameter and is calculated in the table. We now have a full set of green ticks in our status indicator, meaning that we can analyze our model. We can analyze any of the unit processes in the model by clicking on the Analyze button. Let's analyze teacup. Here are the LCA results. We can see from this bar chart the main contributions. Importantly, we can see that the mass flow is sensible. We have a small amount of tea leaves and a small amount of milk going together with our boiling water and our black tea to make a cup of tea. The results are presented as a summary table and also broken down by individually contributing items. These can also be viewed as a tree with various levels of cutoff of impact. We can also look at it as a pie chart and as a bullseye hotspot chart. This is a hierarchical pie chart which shows the contributions of different levels of processes to the overall impact. Here we can see that of the teapot process, the tea leaves are the major contributor. Finally, we have a waterfall chart, which can be useful where some items have an environmental benefit. Let's say we want to assess black tea instead of tea with milk. We can change our parameter set to get rid of the milk by setting it to 0 and have 100% black tea by setting that value to 1. We can save the parameter set and we can reanalyze the model. If we go to the results screen, we can click on the button indicated to rerun the same analysis. Now we can see the milk has gone from the bar chart and only tea leaves remain. The same goes for the mass flow. While useful, it would be better if we could compare black tea to tea with milk. So we can create another parameter set, give this a suitable name. Refreshing at this point makes the formatting nicer. And the teacup process, we can change our milk value from 0 to 0.05 and reduce the amount of tea we need accordingly. Again, we click Save. This time, let's reanalyze from the process map. Click the Analyze button, wait for the analysis to run. And now we can see the comparison between the two versions of a cup of tea. As expected, the amount of impact associated with the tea leaves has slightly decreased, but the increased impact associated with the milk means that the tea with milk has a higher impact. This is broken down in a table. And also visible in the summary table itself. For items in the results where one parameter set is shown, we can choose which one to view using the drop-down on the top left. This concludes the introduction to lcopt. Further documentation and support is available via the GitHub page. Please follow the link in the description below. Thank you for watching.